Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry Lesson 5-5 on inequalities and triangles. This is all the information you should include in your notes today and all the important stuff we're going to cover. We'll begin with the comparison property of inequality. Your textbook gives you this great example. It says when you empty a container of juice into two glasses, it's difficult sometimes to be sure that the glasses get equal amounts. However, you can be sure that each glass holds less than the original amount in the container. And this is a simple application of the comparison property of inequality, which we've written down here. If A equals B plus C and C is greater than 0, then A, the original amount, has to be greater than B. And we're going to use that in the corollary to the triangle exterior angle theorem. So you learned before that the exterior angle of a triangle is equal to the two remote interior angles, like this, x equals y plus z. And that is certainly true. What the corollary says down here, though, is that x must therefore be greater than either z or y. So the next thing we learn is about angles and side sizes in triangles. And what you need to know about this is that just like you can use the sides to show which one is the longest or the shortest, the same holds true for the angles. So if you notice here, we have YR being the longest side at 20. And what you'll find is that the angle that's across from the longest side is actually the largest angle. So in lesson 5-5, they actually ask you to list the angles from largest to smallest. So our largest angle would be G, and then our next largest angle would be across from 14. So it would be Y, which would make our smallest angle across from our smallest side, which would be R. So in order from largest to smallest would be G, Y, R. There's a similar question in the practice, but it gives you the angles, not the sides, and it asks you to list the sides in order from shortest to longest. But you'll notice it only gives us 2 of the angles here, so we need to begin by finding that third angle. To do that, you'll add all 3 of the angles, 45, 75, and angle M, together to make 180 degrees. And then you simply subtract to find that M equals 60. So now that you know all 3 of the degrees of each of these triangles, you can put the sides in order from shortest to longest. So you find the smallest angle, which this case is 45, and you take the side across from that. So the shortest side is MN. And sometimes it's easiest to skip the middle and go straight to the biggest, which in this case would be 75. So our longest line would be OM, which makes the only line we haven't used go in the middle, which would be ON. So those are in order from shortest to longest. Our last theorem for today is the triangle inequality theorem. It says that the sum of the lengths of any 2 sides of a triangle has to be greater than the length of the third side. So here they've chosen 2 sides, A plus B, and it has to be greater than, if you add those together, it has to be greater than the third side, C. And then you have to do that for each of the 3 sides. So you have to add A and C together, it has to be greater than B, and if you add B and C together, it has to be greater than A. So let's do one of the problems from your practice for this. It says, can a triangle have sides with the given lengths? You can choose any sides you want to begin with. I've often found it easiest to start with the smallest sides. So 2 plus 9 will have to be greater than 10, and 2 plus 9 is 11, so that part checks out. We'll continue on. We can do 9 plus 10 has to be greater than 2. Well, 19 is certainly greater than 2, so that part checks out. And then the last part, 2 plus 10, has to be greater than 9. And 12 is certainly greater than 9. So the answer is yes, these can be sides of a triangle. And our last one today also comes from our practice. It says the lengths of 2 sides of a triangle are given. Describe the possible lengths of the third side. So we're going to use the triangle inequality theorem here to determine this. So the easiest thing to do is to begin with the 2 lengths that they've given us. and it has to be greater than the length that we don't know, which we'll just call x here. So 8 plus 12 is 20, so our side has to be less than 20. So again, 20 has to be greater than our side, so our side would have to be less than 20. And then the other way you can do this is to say that the side we have plus 12 would have to be greater than 8. And when you subtract 12 from both sides, we would say that x has to be greater than a negative 4. But that doesn't make any sense because you can't have a side of a triangle that's a negative number. So then let's try the other one. X plus 8 would have to be greater than 12. And when you subtract there, you'll get x has to be greater than 4. So that's our list. X has to be greater than 4 and less than 20. There is a shortcut way to do this, and that is that you can subtract the two sides you're given here, put x in the middle, and add the two sides you're given on one side and make a compound inequality that looks just like this and will always look like that. So on the left-hand side, 12 minus 8 is 4, which has to be less than x, which has to be less than 12 plus 8, which is 20. And either way, you get the same answers. X has to be greater than 4, but less than 20. Good luck, everybody. I hope you guys all do great.